Hello there. In this video lesson we're going to look at a catenoid curve number 2. If you watched the previous video to this, you will have seen how we created a catenoid curve. Just a little bit different from the one that's shown here. It's more of an indent here, more of a curve to it. And what we're going to do in this video is show you some other ways in which you can modify the pattern that appears on the bracelet. So if I go to Fluid Designer and if I go to the bracelets folder, if I just scroll down, this is the catenoid curve that we showed you in the previous video, and this is the one that we're going to use in today's video. So you can see they're slightly different, but they're still based upon the catenoid curve equations, which are displayed in the help panel here. Now I'm not going to actually enter in these equations to create this particular curve. You can have a go at that yourself by going to Add, Mesh, Math Function, XYZ Math Surface, and then entering in the values that are displayed here. Instead, what I'm going to focus on, I'll just switch on Screencast Keys. What I'm going to focus on in this video is other ways in which we can change this pattern. In the previous video we showed you how you can go into edit mode and you can select individual vertices and delete them or dissolve them. We also explained how you can do Control and V on the keyboard and you can slide vertices and change the pattern. And we also explained how you can do the same thing to edges, and in fact you can do similar things to faces as well. Okay, so that's how you can change some of the ways in which you can change this pattern, going into edit mode there. You can also change the pattern by changing this ratio. So if I click it with the left mouse button in this bar here and I'm just dragging the mouse to the right, you can see how you can quickly change the pattern. And if you set it up at the value 1, a ratio of 1, this is effectively the default setting for this. And as you can see, when I go into edit mode, you see all the faces and all the edges and vertices here, and that pattern clearly does reflect what's in edit mode. But as we saw in the previous video, if we move this ratio down, the pattern clearly changes here, but it doesn't change in edit mode. Well, we can actually see what's happening more clearly. If I just come out of edit mode there, if I go to wireframe, and if I change this value here, the crease weight, if I change the crease weight, if I change it to 1, you'll see that the pattern changes. I'll just move it across the screen there a little bit. Now what we're getting here is this decimate ratio is being displayed now in the pattern. If I just move the ratio right back up to 100% again, you'll see that that matches with the original shape, the original catenoid curve, before any changes are made to it. So that's at 1, ratio of 1. Now as we move the value down, what's happening here with this decimate ratio is that we're taking out a percentage of the vertices in the object. You can't see it in edit mode, but you can see it in this mode here where we set the crease weight to 1. Now I actually like rather organic looking models, so I like to enter in a crease weight of 0, which gives you this effect, but there's nothing to stop you entering in a crease weight of 0.2, 0.5, 0.75, or even a crease weight of 1, which is effectively nothing, in the same way that the ratio would be no change, no decimate if you actually set it at 1. So you can modify this value here, the crease weight, and come up with a different appearance to the bracelet. But I'm going to set it back to 0 again. Okay. Now if we click on this one, this other modifier here, the Subsurf modifier, you can see at the moment we've got a value of views of 3. Now don't worry about the render setting of 2. We're not doing rendering, we're doing 3D printing. So if I just worry about the view setting here, if I switch the view down, if I go down to 0, notice that has the same effect as setting the crease weight, or has a similar effect I should say as setting the crease weight to 1. I can still set it to 1, yeah, and you can see there's no change there. So these are connected, and what the Subsurf is doing is it's smoothing off the object. Now smoother objects are more likely to print better, but they also give a different aesthetic. But you know, if you do want this kind of effect, if you do want a bracelet like this with sharp edges, then you can set the view down or not apply a Subsurf at all. But what happens is you change the number of view values, you can see the appearance changes, and the more you increase the view, the smoother the surface becomes. And from experience I can tell you that the smoother the surface, the better chance you have of 3D printing the object. That's not to say you can't print it at a lower value, you still can, but you may have to increase the thickness. What you tend to find is the higher this value, the lower the thickness you can end up with. Now you do need to be careful with the view setting, because every time you increase the view, the faces, which is displayed up here, increases. Now if you go up to a view setting of 4, you could probably still print this object and you'll get a very smooth surface, but notice we've got 447,000 faces there. If we go up to 5, we're probably going above 1 million here, and that will, in fact 1.8 million almost faces. Now that would exceed Shapeways printing allowability, because you're restricted to 1 million faces. So there are limits to what you can set this value to if you were printing at Shapeways, for example. But it is an important value. It smooths off the surface. So that's Subsurf. What about these other things over here? Well, if we remove the tick from replace original, notice what happens. The original is in fact this shell here, which has got no thickness at all. If you actually don't tick replace original here, you'll get a thin membrane filling in these holes, and that thin membrane will not print. It's got almost no thickness to it, so if you try to print this object, you wouldn't succeed. So you do need to have replace original selected. Similarly, boundary, I generally find I always need to have boundary ticked, because if you remove it, notice it has an effect on the edge at the top here, the boundary of the object at the top and at the bottom. And again, I generally find that a smoother edge is more what I would like. So, but you can change it if you want, and you can see you get a more square edge there. I think smoother is generally better. Now these top two boxes here for relative thickness and even thickness, sometimes you want them ticked and sometimes you don't. It does depend on other settings like the thickness factor, for example. So you can see with an even thickness it is thickening up the object, and there are obviously lower limits to the thickness of the object, and you do need to be careful, and you do need to try and measure these. So if I do look at that, that's 1.2 millimeters set there with the even thickness off, and as you can see it's now 1.7, so no problem with 3D printing that. But remember, there's a lot of different parts to your object, so you know you can't just measure one. To play safe, if you can tick even thickness, I would recommend ticking it. Now in terms of relative thickness, if we tick that, you can see things go really weird, really strange. Well, that value, relative thickness, is linked to the thickness factor here. If I change this down to say 0.2, you can see that relative thickness is okay. But of course, you know, that's far too thin to actually print looking like that. And even with the relative thickness ticked, that is probably going to be a little bit too thin to tick. So you do need to weigh up different values here as to what you tick and what you don't tick in terms of relative thickness and even thickness. Now there is one other value that you could change here, and that's offset. Now offset at the moment is 0. If I change offset to its largest value is 1, you can see that there is some change to the model. And if we go to the other end, -1, you can see there's some change to the model. And if we just view it from above, okay, so there's -1. If I type in 0, just watch the model as I do that, it shrinks. If I type +1, it shrinks even further. Now what's happening in this instance is that if we have an offset of 0, what's happening is that this is the original shell of the object. If we've got an offset of 0, this thickness is applied evenly on the outside and the inside. So there's a thickness of 1 on the outside, a thickness of 1 on the inside of that shell, if the offset is 0. If we set the offset at -1, let's just go to view and top view again. We do -1, you see the thickness is being applied on the outside of the object, so all 2 units of thickness is being applied on the outside. So notice our inner diameter is not 65 millimeters with that setting. If we set it at +1, the thickness of 2 is all being applied on the inside of our shell. So it's actually reducing it below 65. Now sometimes you may want the offset to be +1, sometimes you may want the offset to be -1. It does depend a little bit on the object that you're creating. I would suggest starting off at 0 and seeing how that looks. Okay, so we've looked at some of these modifiers here and the effects that they can have on our catenoid curve here. Now when we have the object that we want, as is usual in Fluid Designer, we always go to File, Export, and export it as a wavefront object. And what's actually happening then is that these modifiers are all applied and confirmed, and the object changes into a finished mesh. So I'll just do that. File, Export, Wavefront Object to the desktop, and it's a catenoid curve bracelet, 65mm diameter, and I've called it 002 because previous video we did the catenoid curve bracelet number 1. Okay, so those are some of the things that you can do with this kind of object in Fluid Designer for 3D printing, and there are some other objects which are similar to this bioorganic bracelet, Celadon bracelet. All these other grey ones are curves. As I scroll down, I think there's a few more similar objects. So the Mobius band, organic wire, organic bracelet, split wire bracelet. Those are the ones that are in white, and these Voronoi ones at the bottom can be manipulated in similar ways to as two of you have seen in this video and the previous video. The grey ones are actually all curve objects. Okay, so that's it for this video. Thank you.